Hello, my name is Patrick Pryor, and this is my Physics 2212 Lab 2, Charge Taped Revisited. Intro. So, the goals of this experiment was to use the experiment that we conducted in Lab 1 and the observed information and create a computational model on GlowScript of two charge tapes exerting electric force on the other. And we want to utilize the computational model to predict the amount of charge required on each tape to float one of them above the other. And the results of this, the results from Lab 1 showed that the electric force of a point charge for one piece of tape was 2.723 e to the negative 5 coulombs. And for Lab 2, we discovered that the charge required to offset gravity was 2.748 e to the negative 8 coulombs. So some concepts we need to know. Newton's second law of motion. The force acting on an object is equal to the mass times acceleration. Newton's third law. Every action has an equal and opposite reaction. We also need to know just the net force of a point charge and the electric force equation and how that can be applied to find the net force. Also superposition, which is that the electric field at any location in space is the vector sum of electric fields due to any charge not at that location. Assumptions. So we assumed that each U-tape has the same charge, and we ignored air resistance. We also assumed that the charge of each respective U-tape is distributed evenly across its length. So each U-tape can be separated into segments of equal charge, and that if you added all of these charges or all of these segments together, the charge would equal the total charge on the U-tape. Computational model. This is data from Lab 1 and our constants. So we have our mass, the length, the width, gravity, and the distance. And then these are some of the constants we implemented in this lab. So here's the computational model from Lab 2. It's a lot of lines, but essentially this is the electric field that we have here, and this is the code for the line charge. And this is an example of the superposition principle, because we have two for loops. That's a good example of how superposition is applied. And the results of this lab. So as you can see here, we have our model, and we discovered that a charge of 2.748 e to the negative 8 coulombs was required to produce an electric force with a magnitude equal to gravity. And with electric force equaling gravity, the tape would float. And in here we have our vector, gravity pointing down, electric force pointing up, and our what if. So what if you had modeled each of your tapes as a single point charge, like in the previous lab? We're going to compare the estimated value of the charge that you get when you use your experimental data to produce a point charge model to the value we got with our line charge model. So our Q as a point charge was 2.723 e to the negative 5, and Q as a line charge was 2.74 e to the negative 8 coulombs. So if we modeled each tape as a single point charge, the estimated value of the charge would likely be significantly different compared to the value obtained using the line charge model. In a point charge model, all the charge is assumed to be concentrated at the center of the tape. This approximation tends to oversimplify like the actual thing that's happening, where the tape is actually distributed, the charge is actually distributed along the entire length of the tape. And why do these estimates differ? Which value is more likely to be closer to the real value, and why? These estimates differ because the point charge model assumes all the charge is concentrated in one place, while the line charge model more accurately represents the charge being distributed along the entire length of the tape. The electric field generated by a distributed line of charge decreases more gradually with distance compared to a point charge, and this leads to a different interaction between the tapes. That is all. Thank you for watching. Have a great day.